Why, hello there, lovely ones. So we are going through the calculus questions found in the IEB Paper 1 from May 2022. This one says, in the diagram below, the graph of, and there's the function, where d is a constant is given. And we've got 3 and 0 as a stationary point, which is also an x-intercept. Note, O represents the origin. So when they ask us to calculate the value of d, it's really quite simple. They're just asking us to substitute the value of 3, 0 into the equation. And once we've substituted the value in, we can then rearrange the equation and we find that d is equals to 9. So the next part says, determine the gradient of the tangent to the curve at the point of inflection. And this is actually quite an interesting question because they're talking about the point of inflection, but they're also talking about the gradient of the tangent. So the first thing we need to do is find or determine the point of inflection. And of course we can do that. Let me just zoom out so I can see the function. We can do that by finding the first derivative. The first derivative is of course the way we find the gradient of the tangent, but we then need to use the first derivative to find that point of inflection. And we do that by finding the derivative of the first derivative, in other words the second derivative. That's going to be minus 6x to the power of 1 plus 10. And then we make it equal to 0 so we can figure out what the x value is at that point. So this is the x value at the point of inflection, and that's what we're going to use when we substitute into the first derivative to find the rest of the point. So, or the gradient at least. So we take that and we substitute in. And as you can see, I have calculated it. Remember, you have calculators, so please use them. So just to go over what they're asked again, they're talking about the point of inflection, but they want to find the gradient at that point. So the point of inflection has an x value of 5/3, and we substitute it back into there. This question isn't finished. We still have question C and question D. And of course, we have all of the information we need to do question C. We know that the point of inflection is where x is equals to 5/3, and we also know that the derivative, which or the first derivative, which does form the parabola, is negative. So let's just plot that up here now that I've found it. So it's going to go down like that, and the reason that's important is because we can then see when it is concave up and concave down, and of course it's concave up, leaning all the way to there. And the way we write our answer is we say x is less than 5/3. So question D is quite interesting because they're talking about the function f of x. In other words, they aren't talking about this graph that they've plotted over here, this particular one. But then they're saying that we're going to shift it, and we're going to shift it either up or we're going to shift it down by a certain number of places, and we don't know how many places that is at the moment. All we know is that we're hoping to get a function that has 3 roots, 3 real roots, and that's why I've drawn this over here, so that you can see this is one root, that's another root, and that's another root over there. So I'm sure you just heard my cat meow. I thought I'd take a photo of him just so you could see it's not someone crying in the distance, but I apologize for that noise as well as all of the tapping from the iPad. But anyway, so we're talking about these 3 roots, and we're trying to figure out how we're shifting the function to get a function that gets those 3 roots. And what you'll see is that our points, our stationary points or our turning points, are going to remain the same whether we go up or we go down. So that is the key to this, is finding our turning points. And of course, to find the turning points, we need to do the first derivative. And that's what I've done. I've used the first derivative, I've made it equal to 0, and then I've solved for x to get those 2. And of course, we know that that 3 and 0 is actually this turning point over here. That's how I knew it would be 0 immediately. The other one I'm going to have to substitute into the function. So this is the very ugly stationary point or turning point of the function, and it represents the one that's down below over here, whereas we've got the other one over here. Now we need to figure out how this thing is shifting. And we're going to do that, and I'm switching over colors so that it's easier to monitor what's going on. I'm going to do that by rearranging this given information so that it becomes f of x is equals to all of that other stuff. So f of x is equals to k minus 3. So if we're trying to shift it up so that we have 3 roots, remember that the up value is our y value. To move things up and down, we're focusing on those y values, and that's why we're going to use the y values from the turning points. So the lower one is minus 2 the blah blah over 27, and the higher one is at 0, and of course I have this shift that's happening between k minus 3 and all of those things. Whoopsie. That doesn't look so great, so let's put the 0 over there. Okay, now we need to solve for the expression or the inequality, and I'm going to do that by adding 3 to both sides to, of course, get rid of that stuff, and then that leaves me with an answer of, and yes, I did do this on my calculator, I'm not doing it in my head. Please don't trick yourself into believing that you can do this kind of thing in your head. You need the calculator. Okay, and well, that's it. Much love.